Okay, so we are staying in the Continental Divide for soils 2. All right, so let's go check out soils 2. So again, you're going to need these materials. You're going to be doing a little bit more stuff with this part of the lab as far as prep for carrying out the analysis. Here is your procedure for permeability. It's going to show you right here. Okay, you're going to take your prepped soil, take your corncob skewer, your knife point, anything to create holes in the bottom of your disposable cup. Oh, I did it again too. That's the theme for soils. Here's your screen. Hold on. There we go. All right, so take your thing that you hold your corn with, all right, a knife, whatever, make some holes in the bottom of a disposable cup. You're gonna put your gauze, like gauze you'd put on like a wound, okay? Make sure that if you use enough gauze, so the gauze come folded, don't unfold it and put it in the cup. All your soil is gonna flow through there. You wanna make sure that the gauze stitching is like crisscrossed so that water can flow through, but that the soil stays in the cup. That's the whole purpose of the gauze. It's gonna go over those holes that you just made and then contain your soil in the cup, and it's gonna allow water to flow through your cup. Okay, that's the goal of this experiment. We wanna figure out, well, how fast does my water go through? What is the permeability of my soil? How quickly my water goes through it. And then also we're gonna take a look at retention percentage, how much water is retained by the dry soil, and then how much is actually drained through. So for example, you're gonna start off with your 200 milliliters of soil, as it says right here, okay? Of water, excuse me. It's late in the day and this is like my 4th video, I'm getting tired. Anyway, 200 milliliters of water. Now, if 50 milliliters drains out and 150 stays in, then your soil retained 150 milliliters. 150 is 75% of 200, okay? So you have to figure what the retention percentage is, okay? And the lab walks you through that. It is a basic percentage, okay? Part over whole equals percent over 100, cross multiply, divide. I wish I had like a, it tracked my fingers, or like a whiteboard screen, that would be good. If I were to write that out for you, let me just get a new page. Okay, so part over whole equals percent over 100. So part over the whole, percent over 100. Okay, this would be underlined. So all you do here is you plug in your values, okay? So if we use the example that I just gave you, our whole is 200 milliliters because that's what you started with. So I would type in 200 there. Your part is what was retained for this example, figuring retention percentage. So I would say, okay, well, 150 was retained. To cross multiply and divide, that's literally what you do. So if you remember from school, all right, maybe you've taken this with Miss Radlowski, okay? We are going to cross multiply, all right? So I would times my 150 by my 100, and I would multiply my 200 by percent, okay? So pretend there's another blue circle going the other direction to link around 200 and percent, all right? And so let's see. 150 times 100. It's pretty simple. You just carry your zeros, okay? So 15 times 1 is 15, and then carry your zeros, 3 zeros is 15,000, okay? And then you have 200 times percent, okay? So we take that, oops, I knew that was gonna happen. So we have 15,000, our next step, equals 200 times percent, okay? Now you have to divide out the 200, all right, to get what that equals. And so if you were to divide 200 into 15,000, you get rid of 2 zeros, you'd have 150 divided by 2, 150 in half is 75%. Okay, use your calculator if you need to. So that's all you're doing for retention percentage. Pretty straightforward percentage. And you are gonna do that for this portion here. I believe the questions are in permeability. Okay, then watch this video, because this is more than just dry your soil. This is now crush your soil. Native soils have PEDs, and PEDs are little hardened soil chunks where they've like compacted and dried, and you have these like little nodules, okay? You got to break those up because it's not actually representative of the soil particle size. So this is where you're going to get, you know, a rolling pin or anything that you can substitute as a rolling pin. I don't recommend using glass in fear of it breaking. Okay, but if you have like a super hard Nalgene bottle or, you know, other things, or just, you know, get a rolling pin, break up your soil. And then you're going to filter it through your colander. Now, a colander is a spaghetti strainer, okay? Listen, use a spaghetti strainer, okay? Don't use anything other than that. I have had students say that their holes were 5 millimeters big for the whole colander. No, your spaghetti would fall out, all right? I don't know what type of colander you're using in that kind of scenario, but you're not having dinner if your colander has holes this big in it. Doesn't make sense. So just make sure that you are accurately measuring the hole that your soil is flowing through. Now, we don't have sieves. I didn't require you to buy sieves, so we're using the over-under method, okay? Whatever the size of your hole is, what stays in the colander, what sifts through the colander, that's what you're doing. And then we're doing a feel test, okay? So you gotta kind of feel what it feels like, and that kind of tells you whether it's sand, silt, or clay. And so that's what you're doing for the particle size analysis. And then you're also going to figure out some proportions of your soil and what size they fall into, okay? So that's it. And there's your 2 activities, activity 1, permeability, activity 2, particle size analysis. And that's everything for soils 2. I hope you have fun. I enjoyed doing this one, so I hope you guys do too. And that is all I have for you.